extra time.
All yours.
Okay.
All right. And a free Rubik's Cube to anyone who can beat that time. All right. So welcome Dhruv, our first speaker for the day. And he's going to solve more complex problems using WebAssembly and Go. So Dhruv, over to you.
All right. Good morning, everyone. I hope you had breakfast. We'll just get started now. Okay, so I'm going to be talking about WebAssembly in Go, and we'll see how we can use WebAssembly to bridge web and backend. Now I'm going to take a slightly different approach. I'm going to walk you through a story, and we'll basically go through the journey of a developer from chaos to code harmony, and we'll see how things improve. Now, this comes with an asterisk. I want to highlight this, that the entire demo code that I have today has not been written by me, and that was by design. I used an AI agent to generate the code, and over the course of a long period of time, I saw it evolve. And interestingly, so I used a bunch of different models to critique and analyze their own code, and every time, interestingly, they found ways to improve it and making it better. So that was an interesting experience. And but at the end result, the code review came out super excellent without me ever having to do anything. But I did make fun of it. And one of the main reasons why I did that is because, first and foremost, I do not write bad code. Secondly, I do not write bad code intentionally, right? And third, of course, I was curious how things shape up, right? A little bit about me. So I'll be your guide today through this journey. I'm Dhruv Sagar, and I'm a senior technical consultant at Tarka Labs. I have a little over 18 years of experience building full stack applications, and over the course of years, I've seen, all the good, the bad, and the ugly. And interestingly, as consultants, most of the times we are brought in and we are asked that we have some ugly stuff and we want to make it good. And as a result, over the course of years, I've spent a lot of effort working in production with a lot of different languages. So I'm a polyglot. I worked in Go, Rust, Ruby, Python, Java, you name it, a lot of others. And so I have had an interesting sort of take on it. Every few years, what I do is I pick up a new language, and oftentimes there's an event that happens in December called Advent of Code. If you guys don't know about it, you should check it out. What I do is, I pick up a new language and I try out the problems, solving them in this new language. The reason I do that is because as language designers, they have a job and they come up with a lot of trade-offs. There are certain things that they prioritize that they think are important, and certain things that they feel are where we can compromise. And every language designer has different sets of ideas, and there's often a lot to learn about that. But first and foremost, I'm a learner at heart, and I'm always exploring ways to solve old problems. But not just technical problems like we saw, I solve all kinds of problems. So here's my promise to you today. You leave with working code, and with the realistic expectation and a clear path forward how you can go about using WebAssembly. Okay. So just quickly, I'll go over what you'll be discovering over the next 20 minutes. I'll talk about the universal problem, the problem of code duplication, the nightmares that you have across front-end and back-end. That's one of the major pieces where WebAssembly helps. And then we'll look at some real-world validation drift that breaks productions, right? And then we'll see how WebAssembly helps you solve that. And we'll start with, obviously, what WebAssembly really is. And then we'll see some live demo. where you'll see how the same Go logic can be run both on the front end and the back end, and you have more consistent results. We'll see some performance characteristics as well. We will see some benchmarks, and we will see some optimization strategies that the AI found flaws in its own code and said, yes, these things are the ones that we should definitely improve. We'll then see how the project, the demo project was implemented and what the structure is and the build, and we'll look at some case studies from the demo. And then finally, I'll present you with the action plan about, the most important thing is you'll have a decision framework of how to choose between WebAssembly and JavaScript, when you should use WebAssembly, when you should stick with JavaScript. And then, of course, I'll share you some resources and next steps. So here we start with the story. This is the Act 1. You'll see on your left, we have Alex. He's the hero of our story. Alex, as you can see, he sits on his desk surrounded by a lot of coffee mugs. Some of them were meant to be empty, but the AI refused to make them empty. And so he's looking at multiple code bases on multiple monitors, and he's grappling with a lot of challenges. And so he, like any of our developers, he has a rubber duck sitting on his desk, and he asks the rubber duck, so let me get this straight. I need to validate user emails 3 different places, right? I have to validate them in the front end because I want instant user feedback. I need to validate them in the back end because I want security, because the front end obviously can be bypassed easily. And then also need to do the same validation in my mobile frameworks as well, because reasons, right? Interestingly, the rubber duck stares back, silently empathizing, but it offered no solutions. So next, now we come to the email validation incident that happened with Alex. You see basically 2 code snippets. I've obviously simplified them. So on top you see the front-end code, the code that Alex wrote, not me. He wrote a simple email validation check that uses a regex to validate whether the email is in a correct format. Now, what happened sometime a little later in the day, the business found that there are issues in the validation logic, that it was somehow allowing spaces within the email. And so Alex was told, Alex, we cannot allow spaces in the emails. So please fix your code and make sure that spaces are not allowed. And Alex said, fine, that's simple enough. He goes to the backend code and he fixes the backend logic. And as you can see, previously he had the simple email regex check, similar to the front-end code. But then in addition to that, now he added another guard that makes sure that there are no spaces in the email. And he thinks, well, the job is done. But unfortunately, the next day, he comes to the realization after 2 cups of coffee. And he realizes that the front-end and back-end are validating differently again. So keyword here is again, because it has happened before, right? So that is the issue with having duplicate code, having code in multiple places, trying to do the same thing, and so you have to juggle. Every time you find something or you want to change something, you are left with, as a human, you're left with the choice that you have to consciously make sure that you are doing them in both places. So now we come to the next act, the Act 2, the WebAssembly revelation. Here we'll have the discovery. And so you'll see Alex, very late night. He discovers WebAssembly while doom scrolling Twitter at 2 a.m. He comes across this tweet. It says, just compiled my entire Go application to run in the browser. My users think I'm a wizard. Wizard emoji, hashtag WebAssembly. And Alex looks at this and says, wait, what? What does this mean? So he comes with the first question. What is WebAssembly? So it's important for us to understand what WebAssembly is. WebAssembly, abbreviated as WASM, is a binary instruction format for a stack-based virtual machine, right? And it's designed as a portable compilation target for any programming language that enables you to deploy applications on the web for both client and server applications. Okay, we'll quickly walk through over what WebAssembly is and what it's not. Okay, we've already seen it's basically a compilation target So any compiled programming language can be ported and be run directly on the browser, not just JavaScript. It also promises near native speeds because it's a binary format that runs almost as fast as desktop applications. It is safe because it describes a memory safe sandboxed execution environment, which means that even if something does go wrong, it stays within that sandbox and it doesn't necessarily break your front-end application. Right? That's also critical. And it's universal because it's supported by all major browsers, not just on your machines, but also on mobile. That's also important. But it's also important to understand that WebAssembly is not a JavaScript replacement. It's not here to replace JavaScript, right? Because JavaScript still owns DOM manipulations and UI interactions. It does a fabulous job at that. It's extremely performant. And not only that, a lot many other things as well. We'll see some more of that. And it's important to also understand that WebAssembly is not going to give you a magical performance boost, right? WebAssembly, if you have code that is inherently flawed, porting it to WebAssembly is not going to fix your problems. Right? You have to make sure, obviously, you write good code, and only then, of course, you can leverage WebAssembly so that you can have it on your web. And also very important, this is a myth, that WebAssembly has a complex setup, but it does not. It's actually surprisingly simple to get started. Okay, let me quickly walk you through what the mental model for WebAssembly is, right? So traditionally, when we are used to with JavaScript, you have your entire front-end logic that you write in JavaScript, and it runs directly on the browser. Right? It's simple and straightforward. But with WebAssembly, things have changed. Now what you do is you write your code in a compiled language, such as Go, C++, Rust, Zig, and you can compile that, cross-compile that to WASM binary instruction format, and then that code can then be run within the browser within a WASM runtime. Key to note is it is executed by a runtime, and even though it's portable, there is a little bit of an overhead, so there are caveats. We'll see that. But the key superpower here is that you write your code once in your favorite compiled language, obviously Go, and you run it everywhere. And so this brings Alex to a very critical realization. Okay, he realizes, so when that tweet said that I compiled my Go backend to run in the browser, they literally meant it. It was not some kind of a pun or joke. Okay, so now we come to the Act 3, the performance, and we'll look at some benchmarks. So Alex has a very pertinent question. He says, but wait, won't running Go in the browser be slow? And well, the answer to that is complicated. But let's see. Okay. So this is the demo application that I have built for the purpose of the demo, right? And what I'll quickly showcase is, so obviously in the example where I took about the email validation, that was a very simplistic example just for the purpose of instructions, right? Here in the demo, I've built a slightly more comprehensive one, a little bit more realistic, and I have a few examples. And so what we'll see, so for example, the first one is user validation, right? It has a bunch of fields like email, the name, age, and country, right? And there are some other checks as well. So what we can see is we can run, let me maybe increase the font size. Yeah, so we ran the validation on client side using the WASM code. And what you'll see is the validation went through successfully. Obviously, the data was mined, so it's all good. But also, critical thing to note is the execution time. It's about 2 milliseconds here. Now we'll do the same validation with the same code running on the backend. And you'll see, in this case, that the server-side API validation took about 5 milliseconds, so about 2.5 times, was over 2.5 times faster. Obviously, the server is running directly on my machine, so it's going to be much faster than a realistic application that's running on the internet. But this gives you a perspective, right? This gives you an understanding of the difference of what WASM can do for you, right? It's running directly on your client, and it's running your Go code, which is there in the backend. So you get the performance benefits in terms of, because there's no the round trip happening. So similar to that, let's quickly look. There's also product validation. It does some price checks and things like that. So for instance, if I were to say price is 0, yeah, I want a free product. So obviously it says, okay, it's invalid. Okay, it happened in 1 millisecond. And when I do that with the API, similar, we see similar behavior. And these characteristics are going to be different every time I run it. Obviously, the time is going to vary. Then I have a few more complex, slightly more complex setups. So for example, we have an order detail calculator. What it does some tax calculation, some discount calculation and stuff like that. Again, we can do that using the WASM client side, and we see that happening fast. And we can do the same thing with the server side. Again, this time it was 22 times faster WASM code. So obviously that can vary as well. And also have built a sort of a product recommendation, Alex has built this product recommendation system, which takes various factors into account and gives you some recommendation of what products you should buy based on price, age, and other things. We'll see more on that. And similarly, we can do that with the server side as well. So this was the demo. Let me get back to this thing, right? So as you can see, it's complicated, but there are a lot of benefits, and we'll understand that more in detail. There's one quick lesson I want to give. This was very interesting that when Alex was reviewing his own code, he found a lot of issues, which was fun to see. So here, what you'll see is basically there are two code snippets. The one on top, you'll see obviously there is a nested loop. And what they are doing is, so in this specific example, what we are doing is we are doing a matrix multiplication thing, which is, in this specific case, for example, we are doing a 300 by 300 size matrix, and we are trying to multiply 2 of these, right? And so we are doing this in a nested for loop. Now, in the code above, what we are doing is, we are taking the JavaScript data, and then we are translating that and bringing that, crossing the boundaries from JavaScript land to the WASM land. And so the data, there is some overhead on doing that serialization, deserialization of basically the type conversions and things like that. And so what ends up happening in this scenario, because it's a doubly nested loop, and for something like a 300 by 300 matrix, you ended up happening about 27 million calls of that, right? Which is a large number. And imagine each call having an overhead of some quantity over 27 million, obviously that's going to add up. And the benchmark results show that. You can see very clearly. So JavaScript code, V8 rocks, was somewhere around 35 milliseconds, whereas the bad native WASM code, the one on top with nested loops, it took something about almost 1.6 seconds. So 1,593 milliseconds, which is about 45 times slower, obviously extremely terrible. Right? But now, you look at the second code, it's a lot more sequential and simpler. They do it in 3 stages. What they do is, first they copy over all the data, then they do the computation on top of it, and then they return back that data. So just that small change brought down the benchmarks for WASM to roughly about 50 to 80 milliseconds, a lot more competitive with JavaScript. And obviously, these numbers are sort of, they may vary and stuff like that, but this gives a rough comparison between them. So the key takeaway here is that WebAssembly performance is all about minimizing these boundary crossings. You have to make sure you don't obviously do that in something like a loop and stuff like that. You have to make sure you copy over all the data at first, then do your computations and things like that, especially considering volume of data. Okay. So quickly, now we come to the Act 4. Alex is going to show you about how he implemented stuff. We look at a small snippet of exactly how the project is structured. We have the Go WASM demo, the repository, and under that we have a source directory. Sorry, I need to drink water, but I'll do that later. That's a reminder I have set for myself. Okay, back. Yeah, I should have turned that off. So under the source directory, some important files to look at. One, we have a shared models Go file. This has all our types of the models and accompanying validation logic. Like I said, the actual code is a lot more comprehensive than the one we looked at initially in the presentation. You can check it out later. And we have the main WASM Go file, which is the target for the WASM binary, which will be loaded in the front end. And we have the main server, which is running the server backend. And along with that, we have an index HTML. We very nice build script that eases out the pain of making sure we build everything sequentially and correctly. So this is what the idea is. The idea is you write one function and then you're able to share that across both your front end and back end within these two environments. Right? So again, a small snippet of code elaborating on exactly how you would do a validation for user. Again, this is a very small snippet. The actual logic is much bigger. You can check out the repository, which I'll share later. And this is much better. And this is what the JavaScript bridge looks like. This is what gets you set up with WebAssembly. Right? So there are basically these two statements here. The first one, what it does is instantiate the WASM runtime. And then the second statement, when we call the instantiate streaming, that loads up your WASM module, the compiled one, and then it runs that, because your Go module actually is sort of like an executable. It defines all the things that it needs to do in the sense of setup, global, and things like that. And so once that has completed running, your entire WASM module has been loaded in JavaScript and it's ready to be executed. And so in the last line, you'll see an example of how to actually now leverage it. So you can call, for instance, there's a result, and you can assign that to window.validate user WASM. So this is a function that has come from the WASM land and now is available for you to execute. So now we come to the Act 5. So we look at some real-world victories that Alex has achieved. Right? We'll do some case studies. So we already looked at the demo. We saw how the user and product validation works. Right? So before Alex knew about WebAssembly, he had multiple different validation implementations across platforms. But after he discovered WebAssembly, he created just one implementation. For example, for user, there are some 9 different rules. For product, there are some 7 different rules. And he's able to share that, right? So the result is, and our demo shows that, we have 0 drift between client and server. In the order calculator, what we saw initially before WebAssembly, that there were different sorts of rounding errors with tax calculation, especially if you were to do tax calculation in JavaScript versus in Go, because of floating point precision and other caveats, there can be differences between the results, and that can obviously lead to a lot of issues. What we see after having ported things to WebAssembly, Alex gets penny perfect calculations with 10 different country tax rates. So he's able to calculate better and more accurately. And on top of that, he's also able to build really good features like premium discounts, shipping logic, currency formatting, right? Unfortunately, he doesn't give me a 0 price product, but he does give me a lot of good discounts. And so the result is we have 100% calculation consistency across all environments, right? Yeah. So this is another important thing about WebAssembly, right? It's also makes you the offline superpower. So one day, the project manager comes to Alex and he says, what if users lose internet connection? Now the old Alex, who is oblivious to WebAssembly, obviously has a panic attack. What do I do if users lose internet connection? But the new Alex, who knows about WebAssembly, knows that WebAssembly runs offline. All the business logic works 100% offline, and it's a game changer for progressive web apps and mobile as well. So once your WASM module has been loaded, obviously that needs to happen, but once it has been loaded and cached, everything can be run offline. So this is a small snippet of code. You can see we are checking if the user is offline, and we are still able to use the WASM function and do certain calculations. So not only is it obviously more performant, and we are sharing the same code, but we are able to do it offline as well. Okay, so now we come to your action plan. So Alex has created this strategic decision framework for you. This helps you decide when you should use WebAssembly and when you should stick to JavaScript. So let's look at the factors that are in favor of WebAssembly, right? It's a little bit dense, but let's try to go over it. So the first and foremost is, when you have complex business logic that needs consistency across platforms, right? You don't want to do this multiple times. You want to do this once and share it. There's definitely, even though they may be a bit of an overhead, they may be other factors playing in, but the value add and the wins that you get as a result are tremendous. And then with heavy computation, also we see that in a lot of scenarios, WebAssembly does in fact win. So for example, we will see, in fact I'll run some benchmarks as well. We will see for cryptographic hash calculations when the number of iterations are high, etc. We see that WebAssembly code actually performs significantly better up to 2 times. We already saw that we get offline capability when that is required. That's great. And of course, we have code reuse. And then the maintenance cost of keeping logic in sync is, when that is high, WebAssembly helps out. Now, when you should stick to JavaScript, right? As we already, I think, spoke about, DOM manipulation and UI logic, that's JavaScript's home turf. That obviously is something that JavaScript is very good at. We should always do that within JavaScript, not even try that in WebAssembly. Then for smaller operations, actually we'll see that for example, the matrix multiplication for 300 by 300 matrix, we saw the benchmark results as well, right? It's much faster because of V8 optimization, and that's actually pretty good. And when we are doing some simple API call, simple data fetching, again, it doesn't make sense to write a WebAssembly module for that. And especially key is animation and visual effects. Again, JavaScript and a lot of other stuff are way ahead. And also for rapid prototyping, when you just want to build things quickly and you want to test it out, it might be better to use JavaScript there, right? Because bundle size also matters. So that's also another thing to note, that your WebAssembly modules are going to have an overhead because they get to be loaded. Like for example, even in this example, the module turns out to be about 2 to 3 megs. So that gets loaded, and so there is some little bit of overhead even during the instantiation phase. So the key insight here is that it's not just WebAssembly versus JavaScript. It's about using both strategically, knowing where to use what. Okay. So we are at the grand finale, right? So this is your mission, should you choose to accept it. What you can do is, you can clone this repository, github.com/Dhruv/go-wasm-demo, and you can build it and you can run the server. It builds both the WASM module and the server module, and then you can run the server, and then when you open it, you will be able to see it. That's where the demo was there as well, right? And you have 3 steps to success. You clone the repo, you identify duplication, and then basically you take those ideas and you can apply them into your application and build your own bridge, right? One code base, multiple platforms. It's one quick thing, right? So now, Alex, we are 6 months later. Alex is now 6 months from the email incident. He's at a tech conference, he's presenting, and he's talking about how he reduced the code base by 40% and eliminated drift between achieving consistent performance across all platforms, right? And a developer asks him, but what about the learning curve? And Alex says, if you know Go, you're already 90% there. The hardest part is believing it's this easy. And another developer asks him, what next? So Alex says to him, I'm going to be running full-scale machine learning models in WebAssembly. The audience gasps. That's for another time. So these are the resources and next steps, right? The Go-wasm demo repository is the one that I have built. And these are the official resources. The WebAssembly.org website has a lot of resources. And within this repository as well, you'll find a lot of good documentation covering a lot of very good aspects of that. And a lot of these case studies that I showcased in a lot more detail as well. You can look at that. So the best code, is the code you write once and you trust everywhere. Thank you.